Hello everyone. This video serves as a review of the notes covered on x-axis translations and y-axis translations. So, during piecewise coasters, you had to shift a number of things left, right, up, down, stretch them, contract them in order to make your graphs continuous. You were doing transformations on specific functions. Translations are what we do to the entire graph in order to get it to go somewhere specific. Translations follow function notation and are the process of moving all points of a figure the same distance in the same direction. Now, with regard to the functions themselves, they follow the same rules between translations and transformations. The difference being that transformations occur in the individual equation format, whereas translations occur in function notation, the f of x notation. But the same rules still apply, such as the x's lie rule, in that whatever is inside the parentheses of the function, we will do the opposite of what it actually says to do. But outside the parentheses, we'll still have the same general rules. So, for the next 7-ish slides, we're essentially going to be using this table and this graph to formulate and determine how our main function, this f of x, is being translated by what is given to us. For each of these, I will recreate the table, but I will not be graphing it out for you. That you can do on your own using the table that we provide. Bear in mind, though, that this is the table we're using for these notes. This is not always going to be the table you'll use for every specific problem. You'll be given a table for each specific problem in the future. All right, so first things first. Y equals f of x plus 2. That plus 2 is located inside the parentheses, which means we're going to do the opposite. We're going to take all of our x's, subtract 2 from them. However, notice that we don't have anything outside the parentheses of note. Therefore, our y values are going to remain the same. So from our previous function list, we take all of our x values that are within the f of notation. We're going to drop those by 2, but we're going to leave the y values the same to give us this following table. As you can see, I've taken each of my f values, my x values for my f of x, I've dropped them by 2, because originally we started off as x of -2, x of -1, and x of 0, so on and so forth. But our y values are still just the same. If we were to plot this out, we would see that we've actually shifted everything 2 units to the left. So subtracting 2 from x, doing the opposite of what's in the parentheses, will lead to a left shift of 2. In this case, we have a 2x inside the parentheses. Now 2x means multiply by 2. However, because it's inside the parentheses, we're going to do the opposite. We're not going to multiply by 2, we're going to divide by 2. So all of our x's are going to be divided by 2. So we've taken each of our x values from what they were before and divided them by 2. So originally where we had f of -2 equals 1, we now have f of -1 equals 1. Again, nothing's being done outside our parentheses, so we're going to leave our y values intact. If we were to graph this out, we would see that we'd have a compression along the horizontal axis. So compression along x-axis. All right. Now, we see that our x is by itself in the parentheses. We have a -3 on the outside of the parentheses. Having something outside the parentheses means it's going to affect the y values. So, we're going to have the same f of x values inside the parentheses, but it's our y values that we're going to drop by 3. Basically subtracting 3 from the y values. By subtracting 3 from each of my y values, I've turned my first point from f of negative 2 equals 1 into f of negative 2 equals negative 2. So for this translation, I take whatever the y value was, I drop it by 3 units. This is going to lead to a vertical shift of 3 units down, or a downshift of 3. Now we have our f of x by itself with a 2 on the outside of this. That 2 means we're going to multiply whatever f of x is by 2. So we're going to multiply the y value by 2. Therefore, all of our y values will double. So we took our original first point that was f of negative 2 equals 1. By doubling that y value, f of negative 2 is now equal to 2. This is going to lead to, when we graph it out, a vertical stretch by 2, or a factor of 2. Essentially, we've taken all of our points and we stretched them vertically along the y-axis. All right, negative f of x. A negative sign on the outside of the parentheses means that we're going to take whatever the sign was for our f of x value, and we're going to reverse the sign, or use the opposite sign. Note that since the minus sign is outside the parentheses, we don't care about the x's at all. This only affects the y values. This reversal of taking each of our points and moving it over the x-axis is going to create, essentially, a reflection over the x-axis, or flipping it over x-axis. I'd accept either flipping or reflection. All right, now we have a mix of x manipulations and y manipulations. First things first, we always deal with the x's. In this case, we've got x plus 2. As we should recall, we do the opposite of whatever the x values say we do. So in this case, this says x plus 2, but the x's lie to us. So instead of adding 2 to my x values, I'm going to subtract 2 from each of my x values. Then, this minus sign outside the parentheses means that I'm going to flip the sign of whatever I had as a normal y value. So my y value is going to flip signs, opposite signs of my y values. This now would be a good time to pause the video so you can check to verify that I've taken all of my 6 original points and subtracted 2 from each of the x values, while taking the original y values and swapping the sign on those y values. If we were to graph this out, we would see that we would have a left shift of 2, as well as a reflection or flip over the x-axis. All right, last one. F of 1/2 x plus 3. Remember, folks, we're going to do the opposite of whatever is inside the parentheses. So that says 1/2 times x. So instead of multiplying x by 1/2, we're going to divide x by 1/2, effectively doubling our x values. Then we have a plus 3 on the outside of our function, which means we're going to shift everything up 3 units by adding 3 to all of our y values. Again, folks, this would be a good time to pause the video to check to verify that I've doubled all of my x values, that I've added 3 to all of my y values. If we were to then graph this out, we would see that by doubling the x values, we're creating a horizontal stretch of 2. And by adding 3 to my y values, I'll have a upshift, or vertical shift, of 3. And that, folks, are the translation notes. If you have any questions, please come to Flex, tutoring, or shoot me an email. Take care.